Hello everyone. In this video, let us learn about Lamport's mutual exclusion algorithm. Mutual exclusion is nothing but no two processes can enter into critical section simultaneously. So, let us assume that initially we are having 5 sites and each site maintains a queue to store the requests. Uh, a site can enter into critical section only by requesting, only by sending the request messages. So each site maintains queue. Each site maintains queue to store the requests that are arrived to that site. Right? Next, request. A request message. In request message, the timestamp of the request and the ID of the site who is requesting will be present. So in request message we have two contents. One is timestamp of request message and second one is the ID of the site who requested. Next, so here initially site 1 is requesting, so site 1 updates its own queue with its request. So site 1 updates its own queue with its request and then sends the request message to all the other sites, So on receiving the request message, each site who requests the message also updates their own queue. It means that they store the request into their queues. In queue, a request is stored in such a way that the requests are present in the increasing order of their timestamps. In queue, the requests are stored according to the increasing order of the timestamps, right? So, reply. On receiving the request message from a site, the reply message has to be sent to the requested site. So, each site who received the request message will send reply message. So, uh, in reply message also we are having timestamp and the ID of the requested site. So here timestamp of response is present, or timestamp of reply, we say the same, timestamp of reply or timestamp of response, and the ID of the requested site. Okay. The main thing is that the timestamp of reply has to be greater than the timestamp of request message, because we are not sending the reply before request has been arrived. So it should be guaranteed that the reply message has to be having higher timestamp than the requesting message. Okay. So each site sends the reply message to the site who is requesting. So here timestamp of reply message is 2 whereas timestamp of request message is 1. So the condition was satisfied, and so all the replies has been received by site 1. Now site 1 has to enter into critical section. So a site can enter into critical section only when it has all the replies, when it receives the replies from all the other sites, and it has to be in the front of the queue. So here we are having only single request, so obviously site 1's request is in the front of the queue, or top of queue. uh, front of queue or top of queue. I mean both means that same. So the site has to check whether it got all the replies and whether it is in the front of the queue. So now site 1 also checks that, as it got all the replies and it is on the front of the queue. Now site 1 is eligible to enter into critical section. So site 1 enters into critical section. So after entering into critical section, site 1 performs its execution, performs its tasks, and then it comes out of critical section, that is exits critical section. On exiting critical section, site 1 removes its request from its own queue. The request of site 1 is removed in its own queue, and now site 1 will send a release message to all the other sites. On receiving so the each site receives the release message. On receiving the release message, each site will update their own queue by removing the site 1's requests. So each site updates their queue, and now this is the way how a site can enter into critical section in Lamport's algorithm. Initially we just talked about that the requests are stored in the increasing order of their timestamps in queues. So let us see another example here. So here site 2 is requesting for critical section with timestamp 6. So initially site 2 updates its own queue and then sends the request to all the other sites. On receiving the request of site 2, all the other sites also updates their own queues by inserting the site 2 request. So now site 5 is requesting, it updates its own queue. So here the site 5 is requesting and its timestamp is 4, and site 2 has requested and its timestamp is 6. Whenever a request is inserted into queue, the site has to check the existing requests in the queue with incoming request to the queue. So what it means that, so we have to check the incoming request timestamp with the existing timestamps. If incoming was smaller than the existing one, then we place it in the front of the queue, and else we place it in the rarer part of the queue. So it means that at front side we are having the smaller timestamps, and at rarer side we are having the larger timestamps requests. So while inserting site 5 request in its own queue, it checks with all the other requests. As it has a minimum timestamp, it is inserted in front part of the queue. Now the site 5 request was sent to all the other sites, and each other site also performs the same action, that each other site also checks the timestamps and updates accordingly. So each other site updates, and now each site sends response or reply, sorry, each site sends reply message to site 2, and even each site sends reply message to site 5 also. Now both the site 2 has all the reply messages, and both site 2 has all the reply messages, and site 5 also have the reply messages. Now who has to enter first? So that was decided based on the queue. uh, how means now site 5 is in the front of the queue. Whichever site is front of the queue, and if it is holding all the reply messages, then it can enter into the critical section. So now site 5 is holding all the reply messages, and site 5 is front of the queue. So site 5 can enter into critical section. Once again, site 2 and site 5 both are having reply messages, both are holding them, but site 5 request was in front of queue, so site 5 is entering into the critical section. So now site 5 enters into critical section. After finishing its execution part, then site 5 moves, gives reply release messages to all the other sites, and it removes its request from its queue. So now on receiving the release messages, all the other sites remove the request of site 5, and site 2 already has all the messages, all the reply messages, and now site 2 is site 2's request is on the front of the queue. So now site 2 can enter into critical section. So now site 2 enters into critical section. So here, after entering and exiting critical section, again site 2 sends all the release messages and removes its request from its own queue. On receiving the request message, on receiving the release message, all the other sites also removes site 2's request. So now after performing that, there were no new requests and all the queues were empty. So in this way, Lamport's algorithm to enter into critical section, mutual exclusion algorithm, is performed. So we have some metrics for mutual exclusion algorithms, and let us see that in this session now. So first metric was number of messages required. So for a single entry of critical section, how many messages are required? So initially, if we want to enter into critical section, we need to request. So we need to pass request messages. So n minus 1 request messages are required if we are having n sites. If we are having n sites, n minus 1 request messages are required, and if we are having n sites, then each site has to send reply message. On receiving all the reply messages, then only a site can enter into critical section. So each site has to send reply message. So n minus 1 reply messages are required. After entering into critical section, it performs its task and then exits critical section. On exiting critical section, the site has to send release message to all the other sites. So to send release messages, again n minus 1 messages are required. So totally 3 times of n minus 1 messages are required to enter into critical section and to exit it. I mean, totally 3 times of n minus 1 messages are required to finish one critical section execution. So that's what. And next is synchronization delay. What is synchronization delay? Means that the time taken to enter into critical section for a site after another site is exited. Sorry. Uh, the time interval between one site exiting and another site entry into critical section is synchronization delay. So synchronization delay, on exiting critical section, a site has to send release messages. So how many messages? N minus 1 release messages has to be sent. So the synchronization delay is the time taken to send n minus 1 release messages. sorry, something like n minus 1 messages. So if we are assuming that time taken to send n minus 1 messages is t, then synchronization delay is t. Next, response time. So a site wants to enter into critical section. So at that time taken to start requesting, getting replies, entering into critical section and exiting critical section is response time. It means that whenever it wants to enter into critical section, from that part to exiting into critical section, the time interval between the entry necessary of entry and exiting critical section is response time. So for enter necessary of entering critical section, if we get necessary of entering into critical section, then we request. So time taken for request messages, and then after requesting, all the sites has to send reply messages. So we also have some time to get the reply messages and enter. After getting the reply messages, we need to enter into critical section. So after entering into critical section, we take some time to perform all our operations. So if we say that executing time, so time taken to execute in critical section is executing time. So all these times were combined as response time. So here a request times, as we said, n minus 1 messages takes t time. So request messages time t, reply messages time t, and say execution time say as e. If we take e time to execute, then total response time is 2t plus e. So these are the metrics for the mutual exclusion algorithms, and in this these are the different values of metrics in Lampert's algorithm, and we could even have better performance in another algorithms of mutual exclusion. And this is the end of Lampert's algorithm, and thanks for watching. I hope you understand something. Thank you.